Thank you for having me. Hi, everyone. So I've already been introduced. That's very nice. And today I'll be talking about typing. And I think that's a crazy topic one can pick because typing is pretty controversial, isn't it? But we'll try to navigate that today and maybe learn something from the process. And I am by no means an expert, so I also expect to learn something from you today.
Microphone closer.
Oh, okay, sorry. Like, blah, blah, blah. Oh, all right. Thank you very much. So yeah, maybe let's get started. I'll just plug out for a while so that I can switch real quick and maybe close a little tabs here. A little bit of tabs to close. Okay, let's plug it in again. Yeah, all right. And I also wanted to say hello to all the people who are watching the live stream because I know my folks are watching. And I think some people from my company are watching too. All right, so let's go. Before we start, maybe let me make the full screen. Before we start, I wanted to ask you how many of you use typing regularly? Oh, that's a great number. How many of you don't use typing or don't like it? All right, thanks. I respect that, really. I mean, I understand this point of view. All right. Okay, so let's get started. The title of this presentation is actually maybe not exactly what I want to convey as a message of this presentation. What I want you to get out of this presentation is my unique point of view and my approach to typing. Oh, we got a little sound troubles. And how I navigate that, and how I not get lost, and how I not get frustrated by typing. And I mean, it works, so I decided that maybe I'll share it. What do you think? Okay, is that okay? Like that? All right. What do you think about that? Let's go. All right. First of all, people who want to check in, do it now. I was asked to include this QR code. I checked it. It's not a virus. So yeah, you can check in. And once we're done, we'll go ahead to the next slide. All right, so I think we're all, oh no, not yet. Yeah, let's wait. I think we're almost finished. There are a bunch of people still checking in. Yeah. All right, let's go. Thank you all for checking in. And let's go. At the beginning of this presentation, I'd like to shout out to Carl Mayer, who helped me understand the type theory. It wasn't easy. I'm really grateful. I know you don't have a lot of time, so it was great to have some conversation with you. A user named Decorator Factory in the Python Discord server, who helped me rewire this presentation and the whole idea into something completely new. Jel Zylstra, who contributed a bit in the discussion, and everyone else who encouraged me in this endeavor. This is my first talk ever, so yeah, I expect to learn a lot from this. And who is this talk for? This talk is for everyone. Everyone can possibly get something out of it. And specifically, you can pick your own labels. How do you feel about typing? And then look for those labels in the slides. They're at the top of every slide. And that's most likely what applies to you specifically. Yeah, so a little bit of types just at the beginning. So at the beginning, I'd like to talk about what typing is really all about. I mean, in Python specifically. I don't have a lot of experience typing in other languages. So how I view typing is it's about describing what sets of runtime values can reside in particular variables. So this allows me to understand very well how my program processes data, how the data flows in it, and that's a great way of understanding and delivering software. And what is type hinting in Python all about? Actually, it's all about being expressive in what is the data that you're processing, that you're dealing with. And well, some type checkers will actually type check that and probably say, hey, it's fine. But generally, when we're type hinting, we want to add type annotations. These are those things here. Here particularly we're using nominal types. We're calling types by names. And what are types? Types are generally just sets of possible values. That's what we want to think about types today.
You need to keep higher.
Yeah, maybe I'll keep higher.
On the hand.
Other hand. All right. All right. Thank you very much. Let's go further here. So, if you're starting out, let's learn about two main kinds of types really quickly. Actually, I got a couple books here. I have two books with myself. This one called Grace Hopper, and this one called Grace Hopper. So what I want you all to think about now is if I have a variable that has a type Grace Hopper, then that's what exactly this means. It's just those two objects that I have in here. They're all Grace Hoppers. And I can literally just get a bag. It can just be a symbol of a set, and I can put them in this bag, and it will be my type Grace Hopper. So that's what I want you to think about nominal types. We call them by names, and generally nominal types are defined by inheritance. So when you normally write Python code, you usually run into a situation where you write a class, and some class will derive from it, will be a subclass of it. And that will also be a nominal subtype at the same time. And we also have a different kind of type, which is a structural type. It's anonymous. There's no name associated with it. So what we want to do is talk about its structure. Well, I see that this type has some pages, and those pages have some pretty nice mathematical content. I really like this book. And if someone is interested what type of book this is, I can tell later. Yeah, so those are those two types of types. We have nominal types, which are mainly for picking instances of classes, and we have structural types, which are not necessarily classes, they're just interfaces we want to pick for particular tasks in our functions. So when you're typing, please don't forget about these useful go-tos. I use them all the time, and I do think that if you try to look up information there, you will be finally used to it. And it's not bad. I mean, there are not a lot of resources about typing, especially knowing that typing gets obsolete very quickly. By obsolete, I mean one day you used to write types with optionals, unions, and now you're using pipe unions, like with the pipe character from PEP 604, or you're using built-in generics from PEP 585. So it's it changes all the time. You get type var tuples, you get very new ways of describing types, you get param specs, you get new special forms, you get new stuff all the time. Every release, there's some change to typing. So it's useful to look those up from time to time And also be aware that some problems and some things that I cannot express in the typing system now may be solved in the future. So I want you all to get a look on static typing with Python. It contains a lot of interesting stuff to get better at typing. I especially recommend reading type system guides and type system reference if you want to get a little of detailed knowledge on every of this topic. And my favorite one is type system concepts, which help me a lot in understanding what I'll be talking about here today. I would be. Yeah, so it's a nice specification. It's a fairly new project, but it's a go-to when it comes to how should I use typing in Python and how type checkers understand typing. We also want to refer to relevant PEPs. Typeshed. Typeshed contains stubs. Stubs are files that contain Python syntax code that is used to make. It's like it may be like forward declarations in other languages. For instance, like if you have header files, that may be somewhat similar. You're just like declaring some interfaces. That's how you can look at it. And docs of particular type checkers is also a go-to. It depends on what type checker you use. And Python docs, of course, a lot of interesting modules like collections.abc will come in handy. And YouTube videos from Anthony Sotile. I recommend this guy. He really knows a lot. James Murphy, who made me meet my long-term friend. So I love the channel, and I love the channel for two reasons. Not only for the content. And also my channel, which is empty now, but you can subscribe to it anyway, because I plan to post videos here. So it will be very cool. All right, let's go further. So if you're getting started or look for a refresher in the typing world, you may also want to see a lot of alternatives you have in the typing world. It's not only MyPy and Pyrite that can help you make type-safe code. You may also want to try out Pyre and PyType. And going very, very briefly, because I'm short on time, I think in most of the time you want to use MyPy, and it's in fact a business standard so far, and it's maintained in the Python org on GitHub and stuff. And it's the most popular option as far as I know. And maybe you want to use MyPy if you like strict typing and you want to boost your code up a little and compile your code to C extensions with MyPyC, which gives around 2.5x speed up. That's a quote from the documentation. Then you may want to use Pirate, and you probably use it if you use VS Code. Who uses VS Code here? Yeah, then you probably use VS Code, you probably use Pylance, and then you're probably using Pyrite. I like Pyrite for its different decisions, different approach into typing, and different behaviors. And I actually like combining those two together to make sure that my code is type safe from both sides. But you don't have to do all of the stuff at once. Just be gradual about it. Yeah, you would use Pyrite if you want to check out the type checker used for linting Instagram. It's pretty cool, and I especially recommend, if you're advanced, I especially recommend reading about PISA and reading about how it can help you track down potential security issues like SQL injection or cross-site scripting and stuff like that. It's very cool, and it's essentially about modeling the data flow in your applications. And also PyType for people who don't like typing explicitly and don't like explicit type annotations. You may want to try that. If you know how it should work, if you know how to write good Python code, then use PyType to make you even more reassured that it's type safe and it won't break because of some pesky non-attribute error. How many of you ever got an attribute error on non? Attribute, something, non-type object has no attribute, blah, blah, blah. Yeah, some of you got it, so yeah, I can relate to that. And PyType is pretty specific because it doesn't require you to explicitly type things and instead it relies solely on type inference. And when you give some explicit annotations, it ensures that those annotations actually are met at runtime. All right, but it's not everything, and if you really, really want to follow what's going on in the typing world, I recommend you check this out. It's Red Knot. Who knows RAF here? Yeah, I thought so. And who knows UV? Yeah, a bunch of people know UV. So if you know those tools, then you probably know Astral, who is the team behind those tools. And this is just a screenshot from an issue of Red Knot, a type checker by Astral. Probably a type checker. I don't know, it's a lot of stuff. It's not only a type checker. And if you like rabbit holes, check out based MyPy, based Pyrate, and PyAnalyze. PyAnalyze is pretty interesting because it's not exactly a static type checker, it's a semi-static type checker. And based MyPy and based Pyrate are forks of MyPy and Pyrate that make slightly different decisions. But please don't associate me with the drama behind those tools. I'm just showing you so that you can make your own decision. Some people find based MyPy very useful, for instance. All right, so to conclude, we have 14 competing standards. And there's one on the horizon. It's looming. It's Red Knot. And let's hope together that we won't end up with 15 competing standards. Right? I hope we do. Hope for that. All right, so I want to share with you a strategy that works on my machine to typing. It's pretty interesting. The pseudocode is not really correct, I think, but that's my approach. For every new typing feature, do the following. First, you got to learn about it. How would you know about it if you didn't learn about it? So first, learn about it, and I'll show you how you can learn about typing features without necessarily like reading boring specifications. Yeah, gradual introduction. You're using the fact that the Python typing system is gradual, meaning that it has a form, a gradual form that signifies an unknown set of runtime objects. Who knows what is this gradual form that means an unknown set of runtime objects? An unknown static type. What is it? Does anybody have an idea what that can be? Any, yeah, great. Yeah, it's any, of course. So what we want to do is not only use the gradual typing system gradually, but we also want to apply it gradually, especially if you have large code bases where you have a lot of code and want to be type safe, but it's not necessarily easy to introduce types. What we also want to do is troubleshoot well, and not only troubleshoot, but optionally we can also troubleshout if you feel a lot of emotions and want to release them. And you can also stay up to date, but not up too late. So don't be like me, who stays up late. Yeah, so let's learn about some new typing feature just from a simple example. Let me just, all right, let me show you like that. So we have a funny, silly example of a logger. It's not a production logger. It's actually a very basic erroneous code that to me looks like memory leak because we never clean up the logs list. But what I want to show here is something else. If we run RAF on this, RAF is a linter. We know RAF is a linter. We can run RAF. We can run exactly this command. Of course, depending on your configuration, you'll also find that. Let me just copy it. Yep. And what we can learn here is, hey, mutable class attributes should be annotated with typing class var. So what we're doing is we're looking up typing class var, we're reading about it, and then we're applying it. And once we do, we end up with this little code. Yep. There we go. And now, what this means is that we cannot modify, we cannot override this attribute logs from the instance level, but we can only override it from the class level. And that's often what we want if we have mutable attributes on classes. but not always. But yeah, it's pretty useful in this case, I think. All right, let's go further. What we have here. Now we have some more interesting case. Gradual introduction. Adding types to my code from 4 years ago. I actually digged up a little my very, very old times when I was programming some wild stuff. And what I found was this little code. And yeah. What it was supposed to do is actually be an application for a course, a JetBrains course. And let's run that. Update it. Old code. Yeah, and what we can do when we got this app running, we can tell them what level of task I want to have. And I tell them, well, I want this, and then I have to perform some basic additions to pass all the. Let's do something. All right, maybe let's go with this, and let's go with 0 here, and then I can just write it down to a file. Yeah. What's my name? My name is this, and the results have been saved. That's very old code. And what I want to do is apply types. I want to apply types gradually. And what I can do first is I want to run MyPy on this. Let's do it. MyPy staying updated, old code. And see if we have something to fix. Yeah, we have a bunch of things to fix. Yeah. Let's fix that. I think registry was something related to level ID, so that's an integer, and level instances. Integer level. And as we progress this further, we end up with this code, where we did a lot of stuff to chunk and alias all of the code we need to type this code. We end up with a bunch of helper types, and we're using type alias. We learned a lot. Type alias is useful for creating types that we want to reuse, so we don't have to write tuple of int and int all the time. We can also use dict int level and assign it as a type alias to registry, and the type checker sees this as a type alias and applies this type everywhere. I use the proper name. And now, as we go further down the road, we got a lot of stuff done. This code is fairly type safe. I don't like this code. There's a lot of things to improve here. But what we can do now is we can actually upgrade this code base. How many of you know of the alternative syntax to this that's newer? Oh yeah, you know. All right, so the alternative syntax to this is string or none, like using pipes, like that. Does it look nicer? Is it more readable? How do you think? Not really. You know, everyone has their own taste, but in my opinion, it's pretty readable. I mean, I actually just got used to it, not gonna lie. And what we can do is not replace all those to conform to the new typewriting syntax. We can just run a single command, and it's this. Depending on your settings, again, it may be a little bit different, it may be simpler, but just look at the magic happening. And we end up with a bunch of interesting stuff. Look, everywhere we got some new types. No old forms, no unused imports here. Pretty good stuff. So I really encourage you to use it. Pretty good stuff. All right, so now we got to know how to find stuff to fix, how to learn the new stuff to add to our code base, and we know how to upgrade to newer versions. and it's not really hard. All right. Where are we going next? Troubleshooting and getting it right. Sometimes when you introduce new types to your code base, it's really hard to get it right. Sometimes it's getting overwhelming. And if you got a lot of code to add, I recommend you use tools like MyPyBaseline that allow you to run MyPy, for instance, over your code, like the entire code, get all of the type errors from there, all of the errors reported by the type checker, write them down to a special filter file, and then filter new changes against new typing errors. So what you're doing is saying, okay, this is my baseline. I have these type errors, I have these unresolved stuff, but I want to do it, but I want to fix it gradually. If we have large code bases, it's really hard to add types instantly, and no one would really review that, right? It's like thousands of changes, and you better add them to git blame ignore refs. All right. So that's what I wanted to communicate, and I really want you to work through the errors reported by your type checker and not give up. Please, don't do it. Don't give up. Don't use any. Any is not the solution. It's not the solution. It's just making debts. You know this quote that every lie is a debt to truth. Something like that. It's from a series, Chernobyl. Maybe you know that. And it's right. It's for type checking. It's right. Don't use any if you can type it correctly. Sometimes it's just not ergonomic. But try to type things and try to learn stuff from here. And don't be afraid to refactor your code to meet those principles. Because what I really like about type checking, let me skip a little, is that first, explicit type hinting feels PEP 20-ish. What that means on earth? What does it mean? Well, if we import this, I guess you already know this. If we import this, we'll get an interesting thing. It's called, who knows? How is it called? The Zen of Python, great, yeah. The Zen of Python. And what is written here? Explicit is better than implicit. And I know. It depends on the context, right? It depends. Sometimes explicit is not necessarily better. Sometimes it slows you down. But trust me, in my opinion, and this is an opinionated talk, I do think that if you write an int here as the return type, even though this 5 can be inferred, then in the future, if you somehow mess it up, but you still want this function to return an integer, you'll get this error early, and you'll be able to navigate through it. All right. Yeah, let's go back a little. And if you want to stay up to date, follow the changelogs, update your linter often to get some new rules, and subscribe to my channel, and visit my website and try to print it. It's an interesting Easter egg to discover. All right, want to double even more? Read the new typing peps. Participate in typing discussions. Look, those are pretty interesting. If we load those, like specify type checking false without typing import, overload type hinting for empty sequences, pretty interesting stuff. I encourage you to look at those and maybe contribute to typing related projects or create them. I created 2, class single dispatch and runtime generics. All of those I don't think suit production. I mean, class single dispatch may be actually suitable for production because it's fairly simple and it's well tested. But runtime generics, it's more of an experimental technology with some frame magic and pretty weird stuff. The general idea was to be able to capture the type arguments passed to a generic type at runtime. So when you pass, for instance, bytes to this generic class IO wrapper, then we can access it from get type arguments of self. Yeah, I know, it's pretty interesting. Let's not dive too deep here. And another project, Alex Hall and me made, and some other people too contributed. We made eval type backport, which allows you to use PEP 585 and PEP 604 in Python versions 3.8 and 3.9, whatever that means. All right, to avoid common pitfalls. That's my advice from the battlefield. Mentally separate the typing world from the runtime world. Did you know that this passes type checking? Who knew that? Head up. Nobody knew that. Oh, that's interesting. Why? Why does it happen? Well, we have X, and its type annotation is complex. Complex, by the type checker, is seen as a base type of float, even though at runtime it's not necessarily true. And float is seen as a supertype of int, which again is not true. And we can actually confirm it by simply running isInstance, let's say 1 float. False. But the type checker sees it as okay. And yeah, it's a shortcut. It's specified in the typing specification. So what I want you to do is separate those worlds. Runtime is what matters in the end. You know, yeah. I mean, that's what happens. That's what your CPU runs. That's what your memory gets filled up with. But typing is not to hinder. It's to help. And I want you to separate those worlds. And what we want to do as type writing programmers is to connect those worlds to work together. Sometimes by simply understanding the KVATs and the pitfalls and just moving on, because you know everything in software is a trade-off. Do you agree? Yeah, pretty much. And we can also lie to the type checker to optimize our code. So it's pretty good, right? For instance, you may want to use some types that are costly to import or do not even exist at runtime because they come from stubs. Or maybe whatever else reason is. Or maybe it's a circular import and you don't want to import it at runtime. Typing.type checking at runtime is false. So this will not get executed at runtime. But this will. But the difference between the typing and the runtime world is that the runtime world sees this and sees this. And the typing world sees only this and doesn't look here. So yeah, we can do whatever we want, really. But that's up to us if we really want to make some more debts. All right. Now, another advice from me is to think about types and not classes. Again, classes are useful to create nominal types, structural types with type-dict constructs and protocols. And besides, there are other pretty interesting things like never meaning an empty set. It's just never is in every union you can imagine. Give me like int or none. Never is there. Int, never is there. Never is just an empty set. So if you return never in a function, it means that it breaks your code. It's like raising an exception, right? It doesn't return anything. Because when you have a function that doesn't do anything, like it just has a row pass or 3 dots, so ellipses, what it returns is none, right? Correct? So that's what happens. And when you have special forms, we can do pretty interesting stuff here. With this, we can create our own generics, yeah, literals. Literals meaning, for instance, we can, if you look at typeshed and you look at opening files, the open function, when you have modes, you can have a lot of different modes, right? Like R, like W, like R+, like W+, and stuff like that, right? Or you can have text modes, binary mode, right, and stuff like that. And literal is used there in the typeshed to annotate all the possible modes you can specify. And it's pretty funny to look at it. So definitely check it out. And we also have weird types. Thank you, Carl, for helping me specify to classify those. Just kidding. None is a very weird case because none is a singleton. It's not a class. It's not a runtime class. It's an instance of a runtime class. non-type, but none is used just for convenience to symbolize the literal value none. We also have not implemented, which is a statically unknown type, and you can actually smuggle it everywhere you want. Everything with not implemented will pass. Like you can assign not implemented to a string and it will pass. That's why when you return not implemented in operator methods, that's why it passes type checking. And we also have new type. I barely ever used it. Has someone here used it? Oh yeah. Great. So you have to teach me when it makes sense to use it, because I don't know. All right, and some other stuff I want to advise is to understand the subtyping relation and the Liskov substitution principle. What's the Liskov substitution principle? Every object. All right, wait. Let me phrase it well in my head. We can replace every object with the instance of its subclass. So and it should work. So if we have, for instance, if we have and it makes sense. It's just about containing sets. So for instance, if you have a function compute salary and it takes an employee instance, and it does it also accept an argument of type manager, given that managers is a subtype of employee. So in other words, if we have an operation that spans across all the employees, does it also span across a subset of employees? The answer is yes, of course, and that's the Liskov substitution principle. All right, and I want you to practice the S from solid. Do not ever make functions that return x or awaitable x, or x or coroutine x. Don't do this. Don't actually try to avoid union in return types. Try to avoid them and try to not make other programmers narrow down your types. It will save all of us time. All right. What I like about strict static typing in Python: easier learning of available functionality. Do you know how I teach people getting started with strings? Let's say I want to tell them that they have to replace something in a string. What I tell them, write a string, and you don't even have to annotate it, but let's just annotate that. And write S and then type dot. They don't have to look up the documentation. They don't have to look up ChatGPT. They don't have to look up anything. They just want to replace, and they're looking for replace, blah, 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 blah. There we go, there we go, there we go, and we got it, replace. Then we can do this, and we got the documentation clearly communicated. We can read it. We don't have to leave our IDE. Isn't that fantastic? Isn't that beautiful? And that's because of typeshed and all those types that are actually coming from typeshed. If you look this up, this comes from typeshed. The literal string, count, subroutine index, and stuff like that. All right. Yeah, thinking about developer experience means faster development in the long run, and it means maybe less of technical debt. All right. I already stated why I like explicit type hinting, and I like static type analysis in Python because you are encouraged to rely on single purpose and static non-constructs, although not always, but gradually, and it just feels safer, it feels better, and you can catch errors early, like those pesky non-attribute errors. And the code structure can be fairly simpler to be understood by the type checker. So you have to refactor sometimes, but it may actually turn out to be simpler. And you need a good reason to lie. There's a popular project that lies about types of pretty much its basic components, meaning flask.g and flask.request. Who knows those? Yeah, a couple of people know. They are not what they are typed as. They're actually local proxies that use context variables behind the scenes. But they have a reason to lie. So generally speaking, don't lie. Lying is bad. But sometimes you cannot just express things in the current state of type system. And there's a lack of ergonomicity, and there's a lack of... And sometimes there's just a large developer experience benefit. Actually, Flask.g and Flask request can help us. They give us completions because they're typed wrong. All right, and now things to study. Uh, because I wanted to make a technical presentation, but I instead made like more of a sales presentation. And your homework assignment, if you are interested in learning more about typing, and you can find it also in my pinned repos in my GitHub profile, is to just look up those, just read those new stuff that happened in typing recently. Try to like poke around, find if you like it or not, make an opinion or don't, like ask questions. Try to review your code against those. Some of those are opinionated. Some of those are not really good advices if given your very specific context. But I do think that those things that come from my experience are pretty useful in the long run, and I use those general principles. Of course, sometimes I have to break them, but I use them often, and I think I end up writing some pretty good typed code. So yeah, wrapping up, thank you all for listening and participating. And if you have any questions, I don't know if we have time. Yeah, a few questions. Any questions?
Go back to the slide with everyone from the end.
Which one? Yeah. Yeah, that's a change I love. There are type var defaults, so you don't have to specify this weird, ugly thing. You can just simplify it here. The only caveat is that type var defaults cannot precede non-default type vars, which we know already from function signatures. This does not apply to keyword arguments. And we can also type hint with generic built-in types. That's actually a long, it actually was introduced a long time ago, but I still see some code bases that have old typing, even though we have 3.9 and we can use generic built-in types. We just have to use union if you render our type annotations at runtime. Generally, I think my favorite advice from here is to not use dict string any for annotating fixed structure data, and instead use typedict data classes or other models like pydantic models, whatever models, just because I see this very often. Yeah, and typing self. Typing self is pretty useful because it's a type variable. So if you have a class method that, for instance, is a factory of your class, you often want to, like for instance, let me just show it quick. You are writing a class. For instance, class animal, I don't know, from def class method def from name. I don't know what this means, but whatever. And if we actually type it like this, then, and maybe put a name here, and maybe like do CLS, meaning our class, instance, and then do inst.name. It doesn't make any sense, I know. And then we return this inst. If we type annotate this as animal, all the subclasses will see animal as the return type. So if I had, for instance, class dog, and just passed, and I did dog from name, and I have to inherit from animal, and I use blah blah here, and then I use reveal type to reveal the type, we get animal. What we want instead is dog, because that's our fresh subclass. So what we can do is use typing self. So instead, let's do this. And now what we got is dog. So I really recommend it. And in all those slides, there are more tips to type things better. For instance, review your type guards. That could be type is's. That's from the new PEP 742. Don't bother with the type checking. That's just my advice for not getting lost in the hell of runtime type evaluation. Yeah, some general rules. And a couple of links that may be useful to understanding how to stray away from any. Any more questions? Yeah.
What's the type of product that you wouldn't recommend using typing for? Like, is there any?
Oh, that's a good question. That's a good question. You know, what I think I would refer to, instead of giving you my personalized thinking, because I don't think I have wide enough experience to have experienced something like that. There's in the typing spec, there's a page named reasons to wait a sec, reasons to avoid static type checking. And well, if you simply don't want to, if type annotations can hurt your readability, if the cost-benefit ratio isn't good enough, if your code base fits in your developers' heads, if you maintain high test coverage, blah, blah, blah. There are other reasons. So I think the answer to your question is just this entire page. Yeah. Any more questions? Yeah.
So what's the gossip right now? Which Python version will be strongly typed?
What do you mean by which Python version will be strongly typed? Python will always remain a dynamically typed language and will never change, and type annotations will always remain optional. It will never be a requirement. And it will never be enforced at runtime. Some people tried, I think Mojo tried, to make a static Python, and it kind of didn't work out, I think. Anyway, I do think that the primary goal for the next gen Python is to be faster. You know, all those very interesting technologies like sub-interpreters, specializing interpreter, a lot of those memory management optimizations, new reference counting schemes in GIL-less builds. It's so interesting. So I think we can learn about it way more in the upcoming PyCons. Yeah. Did I answer your question? No version will be like. I mean, Python is strongly typed. If we are sticking to the terminology, strong typing disallows us from adding together types that are incompatible. So in a way, Python is already strongly typed. So for instance, you cannot add 2 plus this, and it already means that Python is strongly typed. I think I misunderstood your question at the beginning. So to answer your question, yes, the current Python is strongly typed. If we could add those together, we would be more like JavaScript, right? Yeah. Any more questions? I think we flushed the bucket. I don't know. We emptied. All the questions are now been asked. All right. Thank you very much for listening. Yeah, and one more very important thing before I finish, okay? Please share your feedback, okay? Please share your feedback about my talk. What would you improve? What would you change? Maybe I did something wrong. Maybe you would strengthen some points. So please share this feedback. It's anonymous. I want to read it. Just get to know, because this is my first talk ever, and I hope you enjoyed it. But I also want to know what were the weakest parts of it, and yeah, thank you very much.